Alright guys, today we're simplifying rational expressions, which means that we have to factor the numerator and the denominator. If you're not good at factoring, something you might need to work on. So after we factor, we cancel out any common factors that are in the numerator and denominator. It's just like simplifying fractions, but only with variables and expressions and things like that. This first problem we have to do bottoms up. And we have to do dots. Bottoms up is in the numerator. Magic numbers are -6 and +2. I'm not going to do all of the process of bottoms up with you, but if you need help with it, you need to ask. So that's x minus 6 times x plus 2. Those are the magic numbers. And then dots is going to be x plus 2 times x minus 2. Now you see it is factored now because the top and the bottom are multiplication expressions and not like they were in the beginning. Cancel out those x plus 2's. Now, when you write your answer x minus 6 over x minus 2, it might look like the x's would cancel out or that 6 divided by 2 would equal 3, but those aren't products. So I can't cancel those. Those are differences. Next problem, 4x squared is a product, so any of that can be canceled. In the bottom, I have to take out the GCF, which is 4x, and I'm left with x squared plus 3. Now, the 4's will cancel, and the x in the bottom is going to cancel with one of the two x's in the top. Just think about subtracting exponents when you're dividing, so that'll leave a single x in the numerator. So cancel that x, reduce that 2 to a 1, and you end up with x divided by x squared plus 3. Now remember, x squared plus 3 is a sum, not a product, so I can't cancel those two x's, like can't cancel an x in the top and the bottom. This third example, we got bottoms up in the top and we got bottoms up in the denominator. That's x minus 3 times x plus 1. Those are your magic numbers. We got x minus 3 times x minus 4 in the denominator. And now that we've written these polynomials as products, then we can cancel any factors. So our final answer is x plus 1 over x minus 4. And no, those x's cannot be canceled because they're not part of a product. All right. If you want to pause the video right here and try these next three on your own, that would probably be very wise. And then you could check them because I'm going to work them right now. So I got magic numbers of +2 and -1 in the top. And in the bottom, I've got dots again, x plus 1 times x minus 1. Cancel common factors. The result, x plus 2 over x plus 1. Why are these called rational expressions? Because rational expressions have ratios, and ratios are fractions. These are all fractions. They're quotients. I hate these bells. They interrupt my video every single day. All right, 3x to the third power is a product. Factor out the 3x in the bottom because that's the GCF. Those 3's will cancel. The x outside the parentheses in the bottom will cancel with one of the x's in the top. That exponent's a 1, not a 4. Cancel that, make that a 2, because now you only have 2 x's up there, x squared. So that's your answer, x squared over 4x plus 3. Again, remember, rational expression has the word ratio in it, and ratio means fraction. These next two, bottoms up again, -9 and 4 are your magic numbers in the top. -9 and 3 are your magic numbers in the bottom. X minus 9 times x plus 4 divided by x minus 9 times x plus 3. Cancel your common factors. X plus 4 over x plus 3. Cannot cancel the x's because those are not products, those are sums. In this next example, we have to factor by grouping, and it's been a while, but we kind of look at the first two and take out the GCF, then we look at the next two and we take out the GCF. So we take an x squared out of the first two, and we're left with x plus 3. And we take a -2 out of the second group, and we're left with x plus 3. Now guys, in the bottom, we skipped over this type of factoring. I'm going to show it to you in class, but it's called the sum of cubes, because 27 is a perfect cube, 3 times 3 times 3. X cubed is a perfect cube, x times x times x. So anyway, now I have to finish my factoring by grouping in the top. Cancel out the x plus 3 in the top and the bottom. Whatever's left is my answer. Again, why can't you cancel out the x squareds? Because they're not part of a product. Product is a multiplication expression. Guys, this numerator, it looks like it'd be bottoms up, but guess what? It won't factor at all. So I'm going to leave this for now. I'll come back to it. So this one's just like the one above it. Factor by grouping in the top. A little factoring in the bottom that you don't know how to do yet, but I'll show it to you in class one day. X times x times x plus 4 times 4 times 4. And it's got a specific pattern for how to factor it, and I'll show that to you one day. Finish doing the grouping on top, which is x squared minus 2 times x plus 4 over what we already factored in the bottom. And you got a common factor of x plus 4. So we'll take that out. And we get x squared minus 2 over x squared minus 4x plus 16. And no, the x squareds do not cancel out because they're not part of a product. Again, this next one looks like bottoms up, but there are no factors of -4 that add up to 2. The bottom could be factored with the magic numbers of +3 and -2, but since the top can't be factored, I'm not going to be able to cancel anything, which means I can't simplify anything. If I can't simplify it, I might as well just write that it's prime. So let's go back up to that top one. Since I could not factor the numerator, I could factor an x out of the denominator, but I can't factor the numerator, so nothing's going to cancel, which means I can't simplify it, so it's prime. That's it.